Hi, this is Mrs. Jones, and today we're going to be looking at atomic and mass number. So last week we looked at the structure of an atom, the structure of the atom, and I just want to recap that before we go any further. So, sorry, my computer's a little meltdown here. If you remember, the central part of the atom is called the nucleus. Okay, so that is the central part of the atom, and I'm going to draw a little, so this is the nucleus there, okay, and the nucleus is made up of two subatomic particles, and remember we chose the red ones being protons and the purple being neutrons, so there are protons and neutrons. Then we have our electrons then whizzing around the outside, okay, and we normally represent them as being crosses, and they are orbiting the nucleus in shells. Now, we also touched upon charges of these subatomic particles. So our protons, if we remember, they were positively charged, okay. Our neutrons, they had no charge, they were neutral. I'm going to put a little 0 there. And our electrons, they were negatively charged. And if you remember, if you have one proton, you'll have one electron, because the overall charge of an atom is neutral. So you have the same number of protons as electrons. Okay? 2 protons, 2 electrons. 8 protons, 8 electrons, and so on and so forth. Okay, so first of all, I want to touch on something called relative charge. Now, it's difficult because these atoms are so small. It's difficult to actually measure the amount of charge. So what they give is a number value, a numerical value of 1 per proton. Okay, so we know that the protons are positive and we can't measure them. That's why it's called a relative charge, because they're relative to each other. Okay, so we know that a proton has a +1 charge. It is positively charged and we give it the relative charge of 1. Okay, an electron, we know, has the same amount of charge but in the opposite. It's opposite to a positive proton, which is negative. Okay, so we'll give that a -1. And because all we're trying to do here is just give it a number value. So our neutrons, as we know, they're neutral, so we give them 0. And you need to learn, so if you're ever asked what the charge is, you can say, well, it's positive, negative or neutral. But if you're asked for a relative charge, you're actually asked for the they're asking you for the number. Okay, so a proton is +1. Okay, our neutrons are 0 because they have no charge, and our electrons are -1 because they are negative. Okay, again, what I want to look at now is mass. Okay, so if you wanted to measure your mass, you would get on a scales and you would measure how much your mass is in kilograms. But here again, the atoms are so small, they're just very difficult to measure their mass. So what we, at this stage at GCSE, we give them a relative mass. Okay, so our proton is given a relative mass of 1. Our neutrons are also given a relative mass of 1, so that would mean that they have the same mass. Now, our electrons, they are 2,000 times smaller than a proton. So, we are going to give them a mass of 1 over 2,000. Okay? So, that just means it's 2,000, that it has 2,000 times less mass than a proton or a neutron. And we also use the term negligible, means very, very small. Okay. Okay, so we've moved on slightly from last week looking at the relative mass of a proton, neutron and electron. Okay, this column here. And what I want to look at now is how this relates to the the periodic table. So I want you to get a copy of your periodic table, and it will be in Google Classroom if you haven't got yours. And I strongly recommend that you just stick to using the WJEC periodic table, because that's the one you'll be given in the exam. Okay, so I touched upon last week that it is the proton that decides what atom it is. Okay, so if we look at this particular atom, it has 2 protons. You can see it has 2 protons. Now, if you go to your periodic table, you will find there are many boxes like this in a table, and what you're looking for is the bottom number to be 2. Okay, so you're looking for a box with the bottom number of 2. Okay, and that number represents the number of protons. Okay, so we know this has 2 protons, so we're looking for the box with the number 2. So if you found that, you should find out that it is helium. Okay, so helium. And this is our symbol for the element. Okay, and this number again is the number of protons. Okay, so those number there. Now, just remember that from what we learned last week, if you have 2 protons, you will also have 2 electrons. So by default, this number also represents the number of electrons, because remember that in an atom, they are equal. The other number that you will find on your periodic table in this helium box is a number 4. Okay, and what this number represents is the mass number. So we've got atomic number at the bottom, mass number at the top. And this mass number here is the number of protons and neutrons together. So ultimately, what is in the nucleus here? Okay, because look, there are 4 subatomic particles in the nucleus. Okay, so we've got 2 protons, 2 neutrons. So we know that the mass number is 4. So that is the number of protons and neutrons. So the bottom number is just the protons, and the top number is the protons and the neutrons together. So what is in the nucleus, basically. Now, the electrons, remember, that's also covered by this number because they're the same number. Okay, so let's have a look at a different one. So we've got lithium here. So remember, we've got lithium. This is our symbol. A symbol for lithium. So this bottom number is our atomic number. And that means that lithium has 3 protons. Remember, if it has 3 protons, you guessed it, it's going to have 3 electrons as well. Remember those charges, the positive and the negative charges need to cancel each other out. So this is our atomic number, number of protons. Okay, and remember, it's just a little note there, number of protons equals number of electrons. And that top number at the top there is our protons plus our neutrons. Okay, and that is 7. So that means in the nucleus of lithium, there are 7 subatomic particles. And we know that 3 of those are protons. So how do we work out the number of not the electrons, because that is the same number there. How do we work out the number of neutrons? Well, what you're going to do is you simply take this bottom number away from the top number. Because if you know there are 7 particles in the nucleus, and you know that 3 of those particles are protons, then what's going to be left, okay, when you take that 3 away, is the number of neutrons. So let's have a look at that. So to work out the neutrons, you take the bottom number away from the top number. So 7, take away 3 equals 4. So we know now that lithium has 4 neutrons. So if we were going to write this down, this is what we like to call it pen in chemistry. So write down the pen. So protons equals 3. Electrons, remember, always the same. So that's going to be 3. And then our neutrons is our our bottom number taken from our top number. So that is 4. So protons are 3, electrons are 3, neutrons are 4. Okay guys, so your assignment this week is going to be on this topic. As always, any problems, drop me a message on Google Classroom and I'll do my best to help you. Stay safe guys.